Welcome to Embedded. I am Elecia White. I am here with Christopher White. I'm also here with Lenore Edman and Windell Oskay of Evil Mad Scientist Laboratories. We're all in one room, so expect some giggles.
Why does that make giggles? Welcome back to you both. I don't think we've had you both on the show at the same time, but separately.
It's nice to be back.
Yeah, we're excited.
Could you tell us about EMSL?
Goodness, that's a big question. Evil Mad Scientist Laboratories started with our hobbies and we started a business around that. And now it's our full-time thing. We've been doing it for almost 13 years now. We make hobby electronic kits and drawing machines and a few retro technological objects.
You have anything to add, Windell?
Oh, that's about right.
Okay, what is your background? Actually, I saw on Twitter that you got a PhD mainly so you could be Doctor Who.
Well, that's not mainly, but it's a great story. So my initials are WHO, and I have a doctorate, so I think I have a pretty good claim to the name. My background is in atomic and laser physics, actually, and I'm not doing any of that right now. Most of what I do is designing robots and helping them get built. I do a lot of CNC work, a lot of programming, a lot of solving problems for customers of our products.
Lenore, how did you get to where you are?
So, for quite a while, I'd thought that my education really had nothing to do with what I do now, except that my degree is in interdisciplinary studies.
That's about perfect.
It is actually very perfect because I do a lot of everything. So I do writing and documentation and customer support and technical support and design and, running a company and all the things that go with that, purchasing and HR. So yeah, I'm very interdisciplinary.
Windell, when we had you on last, you were here to talk about the annotated do-it-yourself science laboratory.
The annotated build-it-yourself science laboratory, but yes.
I was close.
Very close.
Yes.
How did that go? What did it...
Well, believe it or not, I eventually broke even on it.
So the lesson there, of course, is books are a lot of work and sometimes make some money.
And that was 4 years ago, and I've actually just started on a new book project, which hopefully maybe late next year I'll want to come and talk about.
I'm curious, but maybe I'll ask you more off the air unless you want to give us some teasers now.
That'll have to be teasers only, I'm afraid.
All right. I think that was the sum of the teaser. When you say you build kits, I mean, we see a lot of kits. What makes yours different?
Many of our kits make a thing at the end. So once you've built it, it does a specific task, whether that's being a clock or making a robot eye that scans red lights back and forth. So they tend to be a self-contained experience. A few of our kits are more general purpose, like microcontroller things that could be used for a variety of things, but a lot of our stuff is toward a specific goal.
And they're really good.
And they're really good?
And they're really good.
That actually is a difference. Seldom do I get a kit from you or even hear about a kit from you that you can't have a successful outcome. I'm looking at a board now, not from you, from another major company. And then I read the reviews and everybody says, it does this one thing. You're supposed to be able to change it. And I can't even do that one thing. And I don't hear that from your products. It's more, okay, if you put in the time to build it, you build it. How do you, is that quality? Is that documentation?
Yes, it's both.
It's also design, that we're not going to make a thing into a kit unless we're sure that we can have 99% of people have a successful outcome on the first try. And maybe 100 times it takes them a second try, we hope. There's going to be some smaller yet percentage of people who will never get something to work, but aren't going to have a good time pretty much no matter what you do. But we really put a lot of effort into designing things that are going to be successful experiences. And a lot of our things that could be kits otherwise aren't going to have that same level of experience. They're going to have too much of a fiddly step here and there. And we often take those things, we make them into a product that's not an assembly kit. It's a ready-made thing. And so we very often have people ask us for this type of thing that we're making as a assembled product or as a kit as the other. And we're like, no, you can't do that. This has to be this way. You have to have that assembly experience as part of building this in order to make the thing and have the joy of using it and understand how it works. Or, no, sorry, this one is too fiddly. We can't guarantee a good experience to people building it. And so a lot of the overall design choices are really based on what the experience is going to be.
Or on the end user. So some groups of users are not interested in building, and a kit would be a bad experience for them, whereas some want the joy of building it.
What's different about developing a product that's a kit versus, something that you take out of the box and you plug it in and it goes? It seems like there's a huge difference, right?
There's a huge difference.
Yeah. I mean, there's certainly the documentation is very different when you're doing something that's going to be built, that you have to document all those stages of the processes. So that part of it is different than the documentation that you have for someone who's using a thing.
To give another example, in a kit that we have, and I have several different types of tiny little screws, maybe I'm going to pick that this one has a Phillips head and this one is a black colored screw and this one is going to be 2 millimeters longer so you can measure with a ruler and tell the difference. Because every one of those cases where there's a possibility for confusion, you need to step in and head that off at the pass. And a lot of times this makes a big decision about what the mechanical design of the product is, just to ensure that it's going to be easy to assemble.
So what's an example of a kit that you really wouldn't want to sell as a completed product?
So our classic example is the Eggbot, and this is a pen plotter for spherical and egg-shaped things that we've been making since 2010. And the process of putting it together, you walk through adding all these different screws all around the outside, and then when you're done, you have a thing that you need to also adjust all those screws for every different type of thing you put it on. So if you're doing a golf ball versus an egg, versus a turkey egg, all those things have slightly different shapes. And there's an intuition about how to use the machine that comes from putting it together. We actually had a class of users who were taking these machines and then putting them like in libraries and maker spaces, and people were starting to use these things, and they didn't have that knowledge of having built it. So we actually built a more expensive, higher-end Eggbot. We called it the Eggbot Pro, that has a very different set of mechanisms that doesn't benefit whatsoever from that learning experience, that just anybody can figure out how to use it almost on the first try. And that one we don't sell as a kit. We just assemble that ourselves.
So when you have these kits, presumably you're designing the thing itself, the procedure to put it together, the documentation. At what point along that do you deliver it to an unsuspecting person and say, okay, build this and we're gonna watch you and figure out if this is too hard or if we did something wrong? Or do you have like a set of people who aren't very good kit builders to test against? Because
how long do they get to stay there before they become good kit
builders? If you hand it to somebody who's good at assembling things, you're not really going to learn anything, right?
So we have very seldom done that.
Okay.
We have been making... We've been making through-hole soldering kits for quite a long time, and we generally understand the processes and what the user experience will be. And so you don't necessarily need someone to test that out for you because you already know kind of what the gotchas are. Yeah, we haven't done a lot of user testing on our kits.
We've done it a couple times, but usually just for very simple things. For the more complex things, it's really just a matter of stepping through, proofreading, reading over and over and over again, and thinking through what the assembly process is. And we have a lot of experience doing technical support for our other kits, and we really know to a great degree what things people are going to have trouble with. So we spend a lot of time and emphasis on those steps in the assembly process. And the last kit we released has like a 60-page assembly guide, and that's just it takes a really long time to make those, and it takes a long time to proofread those guides, but it's absolutely essential to make sure that people have a good experience with it.
And our customers are really great. And so sometimes they'll catch things in our user guides and so on, and they'll say, hey, I found this thing, or I had a problem here, and then we're able to improve it from that. But they've been wonderful about giving us really constructive, great feedback.
You've been very involved with the maker movement in the Bay Area. Is this back and forth because of that, or is it just because the type of people who would buy your products are the type of people who would say, hey?
I think it's a combination. And I'll say we've been involved with the maker movement worldwide.
Oh, fair enough.
We've been going to Bay Area Maker Faire, and we've also gone to New York Maker Faire, and we have customers all over the world. We've shipped to all continents. And so,
what did you ship to Antarctica?
I knew you were going to do that.
A really big soldering kit that would take a long time to assemble.
Well, I mean, 6 months,
right?
It's not supposed to take that long to assemble, but we don't have proof.
What else have you shipped that has been memorable? Was there a first time I shipped an X, or I have shipped 3,000 Arduinos to a tiny island? I mean, has there been something odd?
The most memorable, I think, there's been a few times that a celebrity has ordered one of our things, and especially when it's a celebrity that we really respect, seeing them use our thing is just an unbelievable experience.
Did you stick in a note? Did you stick in a few extra stickers?
Generally, we haven't done things like that, except for friends. When we ship an order to a friend, we might write a note or things because we know that they'll accept it well. With a celebrity, you get nervous and you're like, maybe I should just treat them normally. They probably want to be treated normally.
Yeah.
Yeah, we get one of our products, the AxiDraw, is often used as a signature machine, and a few household name actors and TV personalities have purchased them for using a signature machine. So when you get that headshot with a signature, presumably some of those are being made with our machines.
So AxiDraw is a computational pen. It's like a 3D printer, but for ink.
It's like a 3D printer, but it's 2D.
It's a 2D printer for ink. Sometimes it's called a printer. So it's a type of pen plotter, which is absolutely a historical type of printer and one of the earliest types of common printers. And in the 1970s and 80s, there were still a lot of these pen-based pen plotters out there and drawing things as a useful standard tool. In my academic career, I got to use a few of these at the tail end of their lives.
And so you said, hey, that thing, we should make that.
No, not at all.
So, I mean, we've occasionally come up with ideas on our own that we're like, we should make this thing. It's cool. And so a lot of our products are made that way. But sometimes people bring us things. They're like, I made this thing. You should keep making it for me.
Is that something you enjoy?
Most of the time we're like, no.
Yeah, 9 out of 10 times the rule is no.
We do have a long list of things we'd like to make, and so most of the time we say no. You should either make it yourself or decide what you're going to do with that. It's an interesting idea, but not for us. But sometimes it seems like a good fit. So AxiDraw was actually a derivative of the watercolor bot, which is a derivative of the Eggbot, and Lindsay Wilson, who made the first AxiDraw, didn't want to manufacture it. And asked us if we wanted to. It's gone through some pretty serious revisions. There's very little in common with the one that he made in the current version. But that's the source of AxiDraw. That it's an interesting geometry, and it seemed like something that was a good fit for us.
It's gotten pretty big. I mean, I see a lot of people using it. Are you surprised?
we were very surprised. We had no idea that we were going to be selling things to real estate agents.
So one of the things that seems to have happened with it, and I don't know the chicken and egg problem here, but I see on Twitter there's this huge plotter community now, and there's a lot of people doing generative art with it, and there's tutorials and all these things that look like Spirograph for adults, I guess. Really, really cool things that you want to put on your wall.
There's some incredible artists using AxiDraw. Did the generative art come first?
Or did it sort of launch a little bit more of that? Or,
if I may, this actually goes back a very long time. From the first moment that there were pen plotters in the 1960s, 1970s, there were artists using them for art. And that has continued, and the resurgence in popularity of pen plotters in the last 5 years, which we can take partial credit for, has given an outlet for a lot of people who are doing digital artwork already in order to take their digital artwork and commit it to paper in sort of a artistic medium sort of a way, that they could take actual archival paper and archival inks and make a thing that looks sort of like it might have been hand-drawn, except with unbelievable precision and unbelievable patience. And so it gives a way for these artists who were doing this stuff to make a print that isn't just sending it to a company that does inkjet printing.
If you're interested in the history of plotter art, the plotter people meet up in San Francisco. There was a talk by Sher Minn about the history of plotter art and looking at ways of doing modern recreations of historical plotter art. But also in the talk, there were a ton of links about the original source materials for the historical plotter art. Lots of really interesting, beautiful works.
And I think that video is online, so we should be able to give you a link for it.
When you started getting people ordering the plotter, did you think that it would be for generative? Did you think that this history would come into it? Did you think, people are going to use it to sign things? Or did you think that this was sort of a broken Eggbot?
Like, oh my gosh, it only draws on flat things.
Exactly.
There's a lot of each of those.
Sometimes when we make a thing, we get to be completely surprised by what people do with it. And that's certainly been the case with AxiDraw. Yes, we expected interesting art and people to use it for unusual media. It will draw on whatever's in front of it, which is unusual for printers. Most printers are made for a particular thing, either paper or a fabric or just the material that they're designed to work with, whereas the AxiDraw will take whatever tool you put in it and draw on whatever you want. So we knew that it had a lot of flexibility and people would do different things with it.
There's a lot of people that continue to surprise us every day with what they're doing with it that isn't pen and paper. For example, maybe you have somebody using it to pipette something, maybe a biological sample into well plates. Maybe you have somebody applying adhesives and or moving around a UV laser to cure some adhesive that's already been deposited. Maybe you have material samples at a laboratory that are different types of composites, that you have a robot arm that puts the material sample in front of the AxiDraw and the AxiDraw labels it. And we hear about all these unusual applications all the time. And it's often surprising what people can do with a reasonably precise, low-cost XY translation stage with a pretty wide area. There's a graduate student from UCLA in the art history department that bought one, and they're hooking up a laser scanner to it to scan paintings in Europe.
It's a portable scanner. You can leave the artwork in situ and take your scanner to the painting and do material analysis on the pigments. So they don't have to request that the artwork be moved, especially if it's a fragile artwork. they can do research in a way that they couldn't before because they have this lightweight, low-cost machine that they can just lug around and put on a tripod.
Wait a minute. We're still talking about this kit that you make that writes pen stuff.
We're talking about AxiDraw, which at the time in this generation was not available as a kit. We have recently made an AxiDraw kit, but up until very recently, AxiDraw was one of those things that we were doing all of the assembly because it wasn't a good fit for a kit.
What was the fiddly bit?
Oh, there's a lot of fiddly bits.
There's still some fiddly bits. So even in the kit version, we have some pre-assembled parts.
It's true.
The calibration, I expect, would be non-trivial?
That's actually pretty easy.
Okay.
But we have some very delicate sliding mechanisms, and just linear slides on their own are a very interesting class of things, and you can buy a very expensive, very high-quality linear slide, but you're always going to have some trade-off in terms of how much friction you have and how much slop you have. And for our machines, we want this trade-off that the thing hardly weighs anything, costs as little as possible, and has no friction at all, and has no slop at all. And if you think about that, that's an empty set. So we've made some fairly clever machined parts, and we use some composites, and we have some very tight tolerance milled parts, and we have something that has a really small amount of slop but no friction, and it is hard to build. It has some complexity to it. It has some tolerance issues, but
and tiny screws.
But if you do build it right, it works extremely well, and it lasts almost forever.
What's different between, I've seen some people take a 3D printer and say, okay, we'll just throw away the Z-axis and tape a pen to it. The precision of this is beyond what you get with a normal 3D printer?
Not necessarily. 3D printers are very precise machines,
okay.
but they're not really designed for pens.
Right.
And there's all kinds of little subtle design choices that you might make. So there certainly are ways to convert a 3D printer into a 2D printer, take away an axis, obviously. But how do you hold the pen? And that's the big thing. Do you have something that applies a certain amount of fixed pressure? Do you have a pressure sensor?
Right.
Or do you have a floating Z stage that allows the pen to ride over variances in the paper? What's the speed like? And with like a fuse deposition 3D printer, there's going to be a speed limit, which is usually how fast your extruder can go. And so they don't necessarily go as fast as otherwise a 2D XY mechanism is designed to go. There's also a certain amount of moving weight that can give certain types of shaking, and there's all kinds of these little trade-offs that if you start looking at any part of it, you'll realize that yes, you could adapt this or that mechanism, but it's not necessarily a better fit.
We've been talking about the artistry of the AxiDraw, but I want to switch gears and talk about PCBs, because there's been a lot of artistry going into that as well. Lenore, you mentioned this to me. What have you seen lately?
Well, so we've been making interesting PCBs for a long time. Back when we made the Diavolino, which was our variant on the Arduino Duomilanova, we put flames on it. Makes it go faster, right?
It's a red board
red
with a black silkscreen and flame graphics all across the backside.
And at that time, that was an unusual thing. One, we were choosing lots of different solder mask colors, which not a lot of people were doing. Most kits had green boards. And so we were doing things like our bulb dial clock kit has 3 different colors of LEDs. So we made the boards red, green, and blue to match which color of LED you would put on which board. So we've been doing some pretty creative things with circuit boards for quite a while. But most recently, we've seen people doing a lot of interesting silkscreen and copper layer art, like art for art's sake on the PCB, whether or not it's a practical electronics device. So some of these things are badges, conference badges and things. Some of them are just portraits. I've seen people doing PCB, pictures of people, pictures of dogs, cats. and so it's been interesting to see so much more attention to the aesthetics of PCBs over the last couple of years.
I kind of found out about that from Sher at Boldport and his kind of crazy solder or copper masks. Where else have you been seeing it? Let's see. It's a Robot Girl who did the stippled one, wasn't it?
I think I did stipple. Well,
you did the stipples on the
Mega Minora
9000, but I would think.
Yeah, she did. She did an early attempt to do a stipple drawing. There was some difficulty with it. So our community, people who have been doing this PCB artwork, have been starting, back 10 years ago when we're during the Diavolino and things like that, and then we've seen this gradual evolution, and then the sort of the explosion with the Badge Life crowd, especially. Yes. The last few years has been astounding.
And then Osh Park, there were some design contests around Osh Park with doing what kind of art can you do just with purple, copper. What's their silk color? Is it white? So you have purple, copper, white, and then do they do gold finish? So I think you get 4 colors. And so people were intentionally just playing with those 4 colors and the overlays to do really interesting artwork and making some contests around it and things.
And yet I've now seen silk screens that come in every color. And just like T-shirts, now you can make whatever you want once you get a silk screen of a whole bunch of colors.
We've recently saw a really amazing product, and this was from a cryptocurrency company called Kong. And their cryptocurrency comes on these bills that look like $100 bills or $5 bills, a bunch of different denominations. And it's actually a flex PCB, this thing that's the size of currency. It's completely flexible. And in one corner of it, it's got a couple little chips soldered onto it. And it's got a little 6-pin header thing that label, or I don't remember if it's 4 or 6-pin, but I think it's I2C. And it's also got a sort of an edge connector on the other end, and both sides of this flex PCB are completely printed 4-color, the whole thing, and it looks like futuristic currency. It just absolutely positively is a full-color PCB, both sides, and the astounding thing when you look at this is that it is actually a circuit board, not that it's a circuit board that's printed. You just don't even notice that it's a circuit board because it's so amazing. And I think the future is going to be a lot of those things.
How much is one of them worth just in terms of the PCB?
I don't know more about this.
But we hide the PCBs inside boxes.
Well,
are we going to stop doing
some
that?
Some projects do, right?
Well, yes, I do. That's true. Most projects do. Is this a maker-only movement?
I mean, Kong, the cryptocurrency, there's not much overlap with Maker there. That's a different set of tech, for sure.
Different set of end users.
Yeah.
And then there are different fiberglass colors now.
Yeah.
I mean, purple became, special for Osh Park.
But that's not even the fiberglass.
That's just the mask.
Is that just the mask?
Yeah, it's standard beige.
Oh, right. The fiberglass is the beige stuff. But I've also seen different fiberglasses and different masks. I saw recently one that was like candy colors, pink and teal, and they looked very cute.
I've not seen that.
So we have started using black fiberglass for our kits, for some of our kits, for the surface mount disintegrated circuit kits are 555 and 741.
But you have a mask on it as well.
And that's clear.
And so when you look at the side of the board, it is black.
Mm-hmm.
Why? I mean, that sounds cool.
Because it's cool.
But why?
Well, these kits in particular are educational. And being able to see the entire circuitry, all of the traces through the clear mask is great. you can see everything that's going on.
I kind of want to go get one now because I didn't realize that. I thought that you could only see I thought it was just
Black on black.
No, I thought it was white.
So we've done black mask on regular circuit boards, and we did that for our earlier disintegrated circuit kits. And they're super sexy, clean looking. We used the black matte finish, so they're great. But we've been wanting to do the clear on black for a long time, and finally made it happen right at the same time that Osh Park started offering that as an option.
But even major manufacturers are starting to do this. Like I saw iFixit tear down to the new Mac Pro, and the motherboard's black on black with black everything, and it's beautiful, but it's like this. Okay, it's very black, none more black.
Is that circuit board actually black core?
I'm not sure
because they've been using black solder masks for years.
Yeah, but I think they did some other stuff on it where a great deal of it was far darker than usual ones. But
is that to make it harder?
I think they just thought it looked cool.
Well, there's that.
My understanding is that the black circuit boards were intended for lighting applications where you don't want extra light bleeding through in certain directions.
Huh.
Are there going to be other colors then? Or I mean, that's a good reason for that. Or when do I get a pink one?
I don't have any information about that.
We haven't researched that topic.
If we come up with a project that requires pink core fiberglass, we will dive deep.
So to go back to designing these things and making them artistic, and I don't remember if we discussed this with SAR extensively, but is that process different than normal PCB design? Like, can you do this in KiCad, or is it I need to go into my vector drawing program? And
it's a lot of both.
Okay.
And the disintegrated circuit kits that we've worked on, the 3.5s kit, the XL741, and now the 555 SE and 741 SE, are collaborations that we have with Eric Schlaepfer, who has designed the circuit board for each of those kits. These are very active collaborations, and we've gone back and forth on these many iterations, and it actually starts with, as much as anything else, a design of what the finished product should look like. So we designed the lead forms, what these, quote, PCB pins are going to look like on the chips. We designed the size and shape of the circuit board, and for these kits, I have specified, okay, this is what the outline of the board needs to be. Here's where the holes need to be for the PEM nuts for the thumb screws, and these holes need to be this diameter, and we have on this kit countersunk holes on our PCB, which is really cool. And those have a spec. And then Eric has designed the circuit board to not just meet those specs, but also to be beautiful. And we've also used a lot of vector drawing for doing all of the labeling on the board, not necessarily the component ref designations, but for every pin label, it's a visible sign, and the graphics. So there's an enormous amount of both electrical engineering and graphic design that goes into these.
And so for some of the more artistic ones, like the Mega Menorah 9000, that was creating artwork outside of a PCB program and then getting it in, and that was a very complicated process.
Yeah, that one was hilarious. So this is the Mega Menorah 9000 is this sort of over-the-top Hanukkah menorah soldering kit that we make, and it's got 9 RGB through-hole programmable LEDs on it that are basically the 5mm through-hole version of NeoPixels or WS2812s, and we made it to look like it's a physical Hanukkah menorah, and it's like, I don't remember, like 7 inches wide or something, and it actually stands up on the table on a stand. And I designed the shape of a menorah in SolidWorks, and I generated from that a rendering. And I took that rendering, created an outline drawing from it, and I brought that outline drawing into the PCB design program. And I also took the rendering of it, sort of as a 3-dimensional shape, and put that into a stipple processing program with 10,000 little stipples to give it a 3D design of that looks like a
So that you have the shadows on the rounded part of the arms of the menorah. All the candle
hinting.
holders, that would be like a brass round arm. You want that shadow to give you that roundness to it.
And then I wrote a program that took those 10,000 little SVG circles of different sizes and converted them into direct Gerber, actually, and merged that in with our Gerbers for the electrical design of the thing in order to create these, really enormous Gerber files that we could send. But it was all, in the end, made in a way that was completely compatible with the PCB fabrication process. It was just real, genuine Gerber, not any weird halftones or anything, and didn't require any extraordinary effort or giant bitmap in order to do it.
I was going to ask how the PCB house responded to that.
Yes.
So the first version of that we actually had made where the front face of it underneath that glorious silk screen was entirely Eneg, so it was all gold coated. And after placing the order, we got a message from the PCB house, and this is just for our prototype order of the thing. We got the message from them, sorry, we need an extra $300 to make this because there's so much gold on this. And I said, well, okay, but how much would it cost, in production if we're doing 1,000 of these boards at a time? How much would that extra cost per board be? And ultimately, we decided against doing it because it was
prohibitive.
No, actually, it didn't add enough versus a yellow to be worth the cost.
The yellow gives it a little bit more of a cartoonish.
A little bit of a glow.
And it looks good. The gold was fun, but it was actually quite understated.
It's it's a matte gold finish. It doesn't gleam in the way that you might hope. So maybe if we'd gone for the hard gold coating, which would have been $4 signs on Yelp, would have been worth it. We'll do the special edition.
Going back to the disintegrated circuits, I saw Eric's enormous 8051. Is that what it was?
6502.
6502. Oh, no. I'm going to so regret that mistake.
That is another collaboration of ours.
When can I buy mine?
Hopefully this year.
How long will it take me to assemble?
We will
It
not.
was a lot of parts.
So you know that thing about some things are good as kits and some things are good as assembled objects?
Yeah, this is not a good kit.
This is not a supportable kit. I am not doing tech support for that as a kit.
Comes with like 1 1/3 reel of transistors.
Yeah, I just needed to check 1,000 things to see what I did wrong. I don't understand the problem.
6,000.
But you have the 555 timer kit. And the original one was through hole, and the new one is surface mount. And for people who have never seen it, can you describe what you mean by disintegrated?
So the disintegrated circuits are what we call faithful and functional transistor-scale replicas of these famous chips. So the 3.5s kit and the XL741 were released in, I think, starting about 2011, 2012. I am terrible at these dates.
There will be a
ago.
quiz later.
I will fail your quiz. These are essentially modeled on the equivalent schematic from the original datasheet from these chips. So if you open up your original datasheet for your MU-A 741 or your NE555, there's going to be a little equivalent schematic there. And Eric was able to interpret that diagram into something you could build out of modern components, which are essentially 2 N3904 and 3906 transistors, some resistors, and we had to actually add a couple of diodes to the 741 kit to make it match the characteristics of those transistors on the die a little bit better, but essentially just a one-to-one transistor mapping between the transistors that you see in the original schematic and original equivalent schematic, I should say, and what's on our kit. And then we've built it into a form factor where it looks like one of these chips too. So the
Like a big version of one of these chips.
Yes, a big version. So instead of being, 0.3 inches across and 0.3 inches wide for its 4 pins, they're like an inch between the pins. And so the circuit board is about 3 by 5 inches. and it sits up above the table on an inch on these sheet metal legs that are made of aluminum that is ground to a nice finish and folded and anodized. And
it looks like the old-timey chips.
Yeah, these are big through-hole dip chips.
Old-timey.
Old-timey.
Nobody uses through-hole anymore.
Your 19th century chips. Player
Victorian.
piano.
I mean, these are some of the earliest integrated circuits. They have been in use for a very long time, and they're beloved, and we get to call them old-timey.
And they're completely old-timey in a sense, but these circuits are used everywhere.
Yeah.
That, if you think about, you buy a microcontroller, even a fancy new microcontroller, and it says it has integrated RC oscillator. What does that mean? That means a 555. They've got a little 555 circuit in there oscillating for you. I mean, these things are just everywhere, every day, in everything we do. And even the discrete ones, they're still making billions of these somehow. Anyway, that's a digression. So they're a few inches across. They look like classic dip chips, and then they have these 8 thumb screws over the pins. They're the actual connections. The pins, the visual pins, are just a decorative stand, but there's these 8 big thumb screws that you can wire up to with just bare wires, or you can clip alligator clips to them, or you can put terminal rings around them. And then the Surface Mount Edition kits, which have the SE on the end, 741 SE and 555 SE, are the exact same circuit, but now they're all with surface mount components, and they're packaged, or the package designed to look like an SOIC, an 8-pin SO package, and they are exactly to scale with the larger ones as SOICs are to dip. So these new ones have a little
I didn't realize
surface mount lead frame
really cool.
with the folded aluminum. And if you hold one up next to the big version, its lead pitch is exactly half of that of the other one. And so it's sort of our in-joke, of course. And it's got these beautifully tiny little thumb screws.
We call them pinky screws in-house because they're so tiny and cute.
And they work the same way.
So you need to do some logic stuff, and then we can build whole computers that are the size of
a room-sized computer.
We can bring back a room-sized computer.
We just need that disintegrated NAND gate, and then you'll be good to go.
Yeah.
What can I learn by building this? It's not just the soldering; it's how a 555 works. And I'm ICs are made of transistors. Who knew?
There are 26 transistors in the 555, 13 of each type.
And you can, with the 3.5's kit, you can go in and you can desolder any one of those and find out why it doesn't work. Or, if you like, maybe you want to hot rod your 741 and you put in some fancy transistors in different places. You can see what the effect of modifying it in various ways is. You can see what the reasons are for all of those different resistor choices. You can put a clip lead from your scope anywhere inside that chip you want to.
Yeah, that's the one that I'm looking forward to.
That you can see what is actually happening inside the chip with however you have it hooked up, if you have it hooked up for a blinker circuit or what have you, and just watch the behavior of the individual transistors.
And it turns something that is digital into something that is analog.
It's analog all the way down.
Well, no, I insist that my world is digital. It's much easier to write code for digital things.
We'll just ignore all those eye diagrams and hope for the best.
Exactly.
It's a 1. It's a 1.
Have you heard of people using the disintegrated circuits in like classrooms and discovering spiffy things?
So I do know that they're used in classrooms. I don't know how they're using them. I haven't seen, what curricula they're using around them.
We get a lot of orders to community colleges and technical colleges for large numbers of the disintegrated circuit kits. So I expect that they're finding their way into a EE department somewhere, and what exactly they're doing with them, we don't know.
That must be hard. I mean, you design these things, you build them, you think this is going to be neat, and then nobody
randos
tells
just buy it, and you don't know what for.
Well, but the thing is, they buy it again, which means that they had success. We don't have to know what kind of success they had, but they bought it again, and they're using it with another class of students. And so that's really rewarding, even if you don't know how it was that they used it or what it is that makes it good for them.
We really like talking to customers about how they're using the things because, for example, the AxiDraw, it was by talking to customers on the phone that we learned that lots of people are using these things for real estate, that people are making envelopes that look like they're handwritten and little notes that look like they're handwritten. And
wait, this is your fault?
It's our fault that they are not written by hand.
They were going to do it one way or another.
And think of the minimum wage employee that we spared.
The minimum wage employee is now monitoring 6 AxiDraws instead of having cramped fingers. Isn't that better?
And they're on a pathway to a rewarding career in robot supervision.
Okay.
They're a pen plotter technician now instead of someone who was writing cramped notes.
Going back to how you design artistic boards, has the software changed to allow more artistry?
It hasn't changed what's allowed, but it certainly made everything more accessible. And I should say up front that I haven't used a whole lot of different PCB design software. I've done a lot of OrCAD and a lot of Jada and a little bit of KiCad now, but I'm not really an authority on these things. But when we were first starting to do circuit board design for Evil Mad Scientist around 2007 or so, we wanted to design some circuit boards that were open source hardware. And it seemed to me absurd to design things that were going to be open source hardware if they were designed by tools that were commercial and couldn't actually be used to open this open source hardware design for free without buying the software. And one of our first Evil Mad Scientist boards was the PEGI board, which is, I forget, 12 by 15 inches or so.
Yeah, 12 by 14.
And Eagle, for example, had a free tier at the time, but their, quote, free tier had this bizarre restriction on it, which was that if you use this software to make or save money, you owe us a purchase. And theoretically, just by not buying the software, I saved money. So I think that their license terms actually specify that every person on the planet owes them money. And I could not get over this.
They also had a size restriction, a really serious size restriction. It was like 3 inches by...
I don't remember.
It was
6
tiny.
inches.
And here we are making 12-inch by 14-inch boards. And
these were low-spec, through-hole component boards without... Okay, they had 625 LEDs, but, not that many
but
components,
really. But it was still
really.
a 2-layer board.
Yeah. It should have been. Anyway, so at the time, there were a couple of different software packages that were open-source software for PCB design. One of them was Jada, Geda, which you might find other people pronounce other way, but most you'll find nobody pronounces it because nobody uses it. And there was KiCad, but one of them, which was Jada, would run on Mac, Windows, and Linux. And so that's the one I picked, and that's what I actually used for most of our circuit board design for quite a few years. And it sort of came out of the Linux and free software community. And one of the neat things about that was that some of the other software out there would actually integrate it in some interesting ways. There's a program called PS2 Edit that will take your PostScript graphics like EPS or whatnot and convert to various formats. And one of the formats that it would output to is the Jada PCB format. So I actually used this. I would do all my graphics design in Inkscape, export it with PS2Edit, and then I would have an outline ready to use in Jada. And I used this for all of our graphics on all of our PCBs for like 10 years. So that Diavolino, Flames, the converting the outline for our Mega Manorama 9000, not the hand-coded Gerber dots, but everything else, and so many other things. We did a lot of that. But its community was not very good, and the program did not grow. And KiCad's community was good and did grow, and this year I had to make a little board, just a little board with 3 buttons and a couple screw holes on it, and a nothing board. But one day I couldn't get Jada to launch for whatever reason. I said, okay, I'll try KiCad. And from the time I started the download, which took like 20 minutes, to the time that I had submitted the board to Osh Park and paid for it was under an hour, having never used this program for the first time and having also downloaded a really cool extension called SVG to Shenzhen that converts your Inkscape outlines into KiCad files. I mean, I had learned how to use the software. I cannot believe how easy that program is to use, how good its libraries are, and the ease of use for anybody getting started nowadays is unbelievably fantastic compared to a decade ago.
I don't know where to go from there. That was like great.
We should talk about seaweed then.
All right.
Wait. Before we do that, convince Elecia that I need an AxiDraw.
He needs an AxiDraw.
What would you use it for?
Plotting things. Plot. I have
You have
plots.
to make that gesture like you're washing your hands when you say,
Exactly.
I have to plot things.
Totally was. It was the burns.
Cover our walls in little things, spirally things.
That's how a lot of people get started.
Custom album covers for my album. This isn't working.
She's slightly skeptical.
Do you want this or do you want a vinyl record player?
I don't want anything.
What? How did we start this conversation?
Seaweed.
I'll get back to you,
I
Christopher.
don't want a vinyl record player. I have to have one. It's different. I'd rather not have one.
See what I have to put up with. Okay.
We got the golden record reissue,
He got that for his father.
but we don't have a record player.
It's
He
not
got
the
one
point.
for his father.
It's beautiful. It's absolutely gorgeous, but yeah.
Yeah, I ended up getting him a turntable to go with it. Because
Because you can't just buy the album.
although, having gotten him the turntable and the records, he was afraid to open the gold records. He hasn't opened them yet.
Oh, they're beautiful. I opened it.
I mean, somebody should explain what this is.
It's it's a replica of the Voyager platters that were sent on the Voyager spacecraft.
Well, it's all of the audio that
Yeah.
was encoded on the spacecraft. It reissued as records, and they're translucent gold.
Translucent gold.
Yeah, the
Nice.
vinyl itself is gorgeous. Yeah.
And it's in a beautiful box with a beautiful book to go with it, with a lot of the images that are also encoded on the record.
And you can get the electronic version if you actually want to listen to what's on it.
Yeah, it comes with a chit for getting your download.
For all the people who don't have record players.
Right, like the aliens.
Okay, so seaweed. You guys go to like a week-long class on seaweed?
It was a 4-day class, and we went last summer, and it was held through the Jepson Herbarium, the Friends of the Jepson Herbarium. The Jepson Herbarium is associated with the University of California, Berkeley, and they do a series of botany classes focused on deep dives into particular topics, and one of them is a seaweed class. And we decided this would be a fun thing to do.
So the Friends of the Jepson Herbarium publishes an annual calendar of what the next year's classes will be. And this year they're doing another one of these seaweed workshops, which is being held in Monterey.
Oh, really?
It is basically the same class that we had last year. We'll be taking a different class through the herbarium this year, but this was honestly just our vacation, and we've never done anything like this before.
And it was a hardcore class. It wasn't just let's go sit on the beach and have a picnic.
It was in between those.
Oh, okay.
So it wasn't a hardcore class in that like we were sitting down with science textbooks. It was getting up really early and getting our buckets and our knives and going down to this private university property and going in the seaweeds with experts. And when I say with experts, it's the curator of algae for the University Herbarium at Berkeley. Her name is Kathy Ann Miller, and she was an incredible facilitator for learning, I'm going to say. She was great.
She one of those people who just loved what she did.
More than that, she loved seeing people learn. She loved when somebody got something. She loved when people had questions. She really loved enabling learning. Also, she loved seaweed.
So she had a great depth of knowledge, a unbelievable willingness to say, I don't know, and a delight in everyone's curiosity. And that really that was fully half of what made this so special, but also just to get out of our real lives for a few days and go do science, even citizen science, amateur science, but one heck of an experience.
What made you pick that?
Well, we love going to tide pools.
Yeah.
And in previous years, the Friends of the Jepson Herbarium had done a nudibranch class, which we thought would be amazing, but they weren't doing it last year, which is when we had found out about it. And so we thought, well, maybe if we learn about seaweed, we'll learn more about that ecosystem.
I mean, they do kind of hang out together, so
right,
it would work.
So this was, as I read the catalog of classes, this was 4 days to go to an isolated set of tide pools that isn't picked over by regular beachgoers because it's at the Mendocino College Field Research Station behind a couple of fences. And, at worst, we're going to have several days with a really low tide to go out and look at things in the tide pools. And at best, we were going to learn a lot about what stuff we were seeing when we go to tide pools.
What was your favorite kind of seaweed?
Okay, my favorite is Hymenema, because one of the things that we did the first morning that we went out, Kathy Ann said, okay, one of everything that you see, bring it back. Just get...
So we had buckets, we had knives, and maybe 16 of us down there at the tide pools, and we all went nuts for several hours at a really low tide. We walked out as far as we could and each tried to get one of everything we saw. We brought them all back to the lab.
And then we got back to the lab and she said, okay, this is going to sound a little bit strange to you, but I want you to all dump your buckets in a big pile in the center of the lab bench here. And so we're all looking at her a little funny, and we all dump our buckets, and we have this mound of seaweed.
We had all brought our plant presses because we thought we were going to be making specimen books of these things. And instead, no, it's not take your specimen and prepare it this way. It's dump everything in this giant, unceremonious pile on this gigantic lab bench.
See, I'd be worried that was a prelude to summoning some sort of eldritch seaweed monster.
It smelled terrible.
It actually did smell pretty bad. Some of those seaweeds were pretty odoriferous.
It's really interesting how some of them have no scent at all, and several of them, just a couple of them, are very powerfully stenchy. And almost all the smell that you smell at the beach
is just those.
Just those.
Huh.
So then she had us sort them. We started out with a sort of general sorting by color and shape. And then as it got to being pretty close to sorted, she put us in pair. Well, she didn't put us. She said, grab a partner and focus on one or two things. And so at that point, I was with another woman. We were sorting through this pile of fluffy red stuff, and we're sorting them, and we're like, well, these look the same. But this one has spots, this one has stripes, and this one doesn't. But they look the same. And so we sorted them to these three piles.
Can you describe what that algae looks like in general?
So it's this fluffy red algae with the leaves are kind of diverging into fingers. So clumps, little fist-sized clumps of red fluffy.
And impeccably flat locally.
Right. The leaves of it were very flat. But in the water, it would have the appearance of being kind of ruffly. But once you got it out, and you could flatten it out. So we're looking at these flat bodies, and some of them had in the flatness had stripes, and some of them had spots, and some of them didn't. They were just sort of plain solid color. And so Kathy Ann came by, and we're like, we think that these are similar, but they're different. And she said, we get to talk about the life cycle. These were three different genders. One of them was male. That was the one without anything. The females had the bumps, and the ones with the stripes were the tetrasporophytes.
What are tetrasporophytes?
Those are the ones that have the diploid. Is that right? No. I don't remember exactly. But basically, there are different parts of their life cycle, different generations, where some of them have haploid gametes and some of them have diploid. So I guess the tetrasporophytes
Had four.
Had four, yeah. Anyway, it was another gender that was generational, and so we were looking at the same plant, or the same algae, but it had three different
Same species, but
but three different genders. What was really cool after that, we learned that there were some of them that have this difference of the three different genders, and yet they're not visually similar. So the male and female may be somewhat similar, but the tetrasporophyte was just a sludge that would coat a surface, like a
Weird.
yeah, and the female would have bigger sort of leaf bodies.
we learned a lot about. There was one classroom session. We learned a lot about the life cycle of different types of algae and the things that
The things that go on in the plant world, man, it's crazy.
Crazy.
if the conservative talk show hosts ever hear about this, there's going to be hell to pay.
I mean, we haven't even talked about the green algae and their weirdnesses. Like, how can you?
So you have, the mammals are relatively easy. You've got, sperm and an egg. You've got these things that each have half of a genetic code, and then you mix them together. You get a full genetic code. You get the diploid rather than the haploid gametes. But with some of these algae, you can have an entire organism that grows up and is indistinguishable, and one of them is a haploid and one of them is a diploid. Like, this entire organism either has half the genetic code or the other has twice the genetic code, and you can't tell them apart by looking at them. And I just don't understand how this works. So maybe I need to learn some biology.
Trees have that too. That how many sets of genes they have is not. It's not like us where we have so many chromosomes, and if you don't have that many chromosomes, bad things. Trees are just like, 3 or 4 copies, whatever. Oh, you have 2 copies? Okay, we can be friends. It'll be fine. It's weird.
So Hymenema was my favorite because it was the one where I discovered about the life cycle weirdnesses of algae because of the way that we did the sorting process. I got to learn that the differences were about all of these crazy variations in life cycle.
There's a book called Slime that came out not too long ago by Ruth K. something. Oops. And it's all about algae. I totally recommend it. I had a lot of fun.
One of the participants in our class, Josie Iselin, just published a book about algae with beautiful photography.
Oh, this one was all words.
I will
we'll trade.
Get you a link, and you can add that to the show notes and things. It was a really beautiful book that we got to see during the class because she had her pre-press copies. But yeah, and so that was one of the other neat things about this class is that you're with maybe 20 other people for a set of time, and you get to know them, and they're all science geeks. They're all there because they want to learn something about this really esoteric topic, and it was so fun.
What are you taking this year?
We are, we're not committed to it yet, but we're looking at a hike around Mount Shasta, looking at the biology there. Another 4-day program.
So alpine ecology.
Yeah, that has the charismatic megafauna. There's all the cute stuff.
You just like saying that.
I do. I just like saying that.
She said that in the car randomly while we were driving.
I don't just randomly say charismatic megafauna. Usually there's a deer or something.
So there's another class in the catalog this year that is a desert crust class. And I think that was the class where they used the description charismatic microfauna.
Microflora?
Charismatic microflora.
You little itty bitty plants.
Who could resist?
Yeah, exactly. So it being in a desert doesn't make it quite as appealing, but I love the way it was described. So the seaweed class was called the North Coast Seaweed Frolic, which
sets the tone, doesn't it?
That's the show title.
Very inviting. And we really did have a wonderful time. And this isolated beach that we were at, there were abalone shells, huge size abalone shells just sitting on the beach because no one is allowed to remove anything and nobody can get there because it's behind fences.
Not to mention there were giant full-size abalone like everywhere on the rocks.
That too. We'd be mucking around in the seaweed and be like, oh, watch out, there's an abalone right there. And it's,
you never see those anymore.
12 inches across.
I've got to invite some sea otters up there.
I don't think we saw any sea otters.
They haven't gone far enough because there are sharks in their way. And so they can't grow out of their...
Can't get past San Francisco Bay? Is that
yeah,
right?
that's where the
and
sharks
this is pretty far up there.
North Coast.
We were up at Point Arena.
You all listen for this sort of thing, right? I mean, this is why you're here, exactly.
We talked about computers last week.
Yeah, it's fine.
We talked about PCB design. We talked about eye diagrams. I mean, what are we doing wrong?
But Evil Mad Scientist, as we said, started from our hobbies, that we were doing electronics for fun, and it got out of hand.
100% accurate description.
And at that point, the thing that you had been doing for rejuvenation and recharge is suddenly your job. You have to find new things that make you feel good again. And now that we run our own business, it's really hard to separate ourselves from that. And so doing something like 4 days completely away with a group of people that we wouldn't otherwise have interacted with is a great way to do that.
What, SuperCon isn't a vacation enough for you?
SuperCon actually was kind of a vacation.
Oh, that's nice.
Because we weren't giving any talks. We hadn't brought any demos. We just went down and participated in the conference, which is something we never do. So that actually was kind of a vacation.
But I understand it's if you make your hobby your career, you need a new hobby because you can't spend all your energy in one place or it just kind of gets sad, at least for me.
What if all of your hobbies are frustrating and annoying?
Well, you could come...
You could just buy more gear. Isn't that your usual?
Yes.
I was going to say, you can come join us on our other hobby, which is astronomy now. We're doing astronomy outreach as one of our outlets.
Yeah, you've been going up to the Wilson Observatory.
Fremont Peak Observatory.
Peak. Sorry.
And it's a tiny little observatory with a very large reflector telescope, which means you get to look through it with your bare eyes rather than an imaging system, and get to see deep sky stuff.
Astronomy, sadly, was the first hobby that I burned out on.
Oh, no.
About a decade or so ago. I'm trying to get back into it, but I haven't actually.
We got a thing for you.
Yeah. If anybody hasn't heard about Beetlejuice, you should go check out that news.
I haven't seen if it's changed too much lately.
Nobody really can tell because it's a full moon.
Oh, right.
And we have to wait for the moon to go away before we can
We could blow up the moon. That would make it so we could see it easier.
That will solve all of our problems.
Well, one of the other reasons we have you in studio is because today is one of the low tides of the year, which means we need to get out of here so we can go see the tide pools.
Excellent.
Windell, do you have any thoughts you'd like to leave us with?
Not really.
Lenore, what about you?
It's okay to make a business of the things that you love. You just have to take care of yourself while you do it.
Good advice. I mean, even if you don't make a business of what you love, you still have to take care of yourself.
That is so true. So true.
Our guests have been Lenore, Edman, and Windell Oskay, the founders of Evil Mad Scientist Laboratories. Check out their website, www.evilmadscientist.com. Thank you both for being with us.
Thanks for having us.
Thanks.
Thank you to Christopher for producing and co-hosting, and thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on embedded.fm. I should have a quote to leave you with, something about slime and algae and cyanobacteria and the future of the world and how we're all going to be saved with climate change if we just get the right seaweed. But I didn't actually remember to get one, so you're on your own. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you. Welcome to Embedded.